we can agree that water is a pretty special substance, right? I mean, not only do we use it to drink and to cook and to wash our hands and to brush our teeth, all sorts of things throughout the day, but this is the only substance that scientists have been able to find that actually keeps things alive. Without it, we can't survive. We can go quite a while without food, but water, we can't even go more than 3 days. Now, did you know that not only is water essential to life, but it's actually really cool too? And I don't mean temperature cool. What I mean is that water has its own special properties. All things are made up of tiny particles called atoms, and a single water molecule is made from 2 hydrogen atoms and 1 oxygen atom. You have probably heard water called H2O before. This is the chemical formula for water, and it refers to the number of atoms and the elements that make up a water molecule. The hydrogen atoms have a strong negative charge, and the oxygen has a strong positive charge. Their opposite charges create a unique connection called a polar molecule. A polar molecule is a molecule that isn't just positive or negatively charged. It's both, kind of like some magnets. This is the reason that water has a lot of unique properties we are going to see in action today as we run some experiments. Okay, let's take a quick break with a quiz. We'll start with an easy one. Teachers, you can pause the video to allow students time to answer the question. True or false, the chemical formula for water is H2O? Yeah, it's true. Give yourselves a pat on the back. I'm sure you got that one right. If you would like to follow along with me as I run the experiments today, these are some of the materials that you want to gather before we get started. Once I read off the list, you can pause the video, gather the things that you need, and then press play whenever you're ready to begin. So we're going to need paper towels, both for running some experiment as well as for cleaning up, a plastic fork, some paper clips. We need at least 20. If you have more than that, that would be great. A bowl filled about halfway with water. I have 3 cups here filled with different colors of water that I dyed with food coloring. If you don't have food coloring, that's perfectly fine. You can run the experiment without it. And if you only have 1 color of food coloring, that's okay too. We can certainly look at that with or without that material. I have a magnifying glass. That will be great for looking at the interactions of the water droplets up close. A penny and an eyedropper or a pipetter. Now those come in all different shapes and sizes, so whatever you can find or whatever you have available will be perfectly fine for this experiment. Whenever you're ready, let's get started. So the first 2 sets of water properties that we're going to take a look at today are cohesion and adhesion. Cohesion is easy to remember because you're talking about when 2 water molecules are sticking together, so they're cooperating. Adhesion is the opposite of that. It's when water molecules are sticking to other objects. So that's going to be a very different reaction. We're going to be able to see these 2 water properties happening at the same time, simultaneously, because we're going to take a look at what happens whenever you put water droplets onto a penny, and you're going to get to test out to see how many water droplets can you put on the penny before your bubble bursts. So for the balance beam, you're going to use your pipetter to balance water droplets on the surface of the penny. So make sure that whenever you're doing this, that you're holding your pipetter or your eyedropper straight up and down so that you are getting the same amount of water in each of the droplets. This is really important to make sure that when you're running this experiment, that the amount of water that you're dropping onto the penny each time is the same. Now you can see that a bubble of water is starting to form on the surface of the penny. This is the cohesion of the water molecules sticking together, and then adhesion, where the water molecules are sticking to the penny and trying to hold its shape, Let's see how long it goes. We've got 25 droplets. Make sure you use your magnifying glass to take a close look. Let's take a break with another quiz. This one's multiple choice. Hope you've been paying attention. Which water property causes water molecules to stick to the surface of everyday objects? Is it A, cohesion, B, fusion, C, adhesion, or D, funyuns? Think you know the answer? It's adhesion. Next up is surface tension. Think about a time where you might have been walking near a pond or a lake or a stream, and you look down at the surface of the water and these little tiny bugs just gliding across with no effort at all. This is one of the best examples of surface tension found in the natural world. Those bugs that you saw, those are called water striders, and they're giving us a perfect example of how surface tension, which is caused because of the cohesive properties of water that we've already seen, the polarity of water molecules create this strong bond with each other, and whenever a lightweight object is carefully placed on the surface, it doesn't break and it doesn't fall through. Now you're going to get a chance to try that with our bowl and our paper clips and our fork to see how carefully you can place paper clips on the surface of the water and to see how many you can get to float before breaking the surface tension. So this event is called Backstroke because we're going to be placing these paper clips very carefully on the surface of the water, almost like they're swimming, doing a backstroke across the pool. Now, I've sped this up a little bit because it takes some time to get them all on there, but you want to make sure that you're taking your time and carefully placing the paper clips one by one and keeping track of how many you can get onto the surface before the surface tension breaks and they start to fall to the bottom of your bowl. You can probably get a lot more than you expect if you take your time and are really careful with this. I was able to get 34 paper clips on the surface of the water in this bowl. Now, another thing to keep in mind is that the surface tension can be broken by things. Whenever water gets contaminated with soaps, the surface tension of the water is immediately disturbed, and you can see our paper clips start dropping so quickly to the bottom of the bowl. And now, this is just a couple of drops of soap added, so think about things like pollutants that get into our streams and eventually into the river, and how that might impact those water striders and their ability to glide on the water. For one more quiz break, another multiple choice. Which of the following is an example of surface tension in the natural environment? A, leaf floating on a pond. B, sheets of ice covering a creek. C, donut float in a pool. Or D, water striders gliding on water. It's D, water striders gliding on the water. Good job. Now for our final experiment. We're going to take a look at a property called capillary action. Now this one's pretty interesting. This is where we're going to see a combination of cohesion and adhesion working together, and water is going to defy gravity. This is the magic of water. We're going to get to see exactly how these properties work together, and whenever they do, we're going to see water move vertically out of a cup and into another cup. Capillary action is where water molecules are sticking to the surface of another object and moving away from the surface of the earth and defying gravity. So let's take a look at how a paper towel can move water molecules out of a container and into another. I've moved the colored water into some smaller paper cups so that you can see this work a little bit quicker in the video, but you can see that the two small cups that I've placed between are empty, don't have any water in them. You're going to tear small strips of paper towels that you can fold over so that they're in both the colored water cups and in the cups that are empty. You're going to do one from each color into the empty cups. So you'll end up having 4 pieces of paper towel for 3 colors. If you're only using one color, you would just have 1 strip of paper towel and 1 other cup. But you can see already in this video how quickly the color starts to change and move across the paper towels and into the empty cups. Now, not only is the color moving across the paper towel, but so is some of the water. Now we can see with the paper towels gone that there is actually colored water. This one's a little bit purple. And then this one looks yellow, but whenever you take a closer look, it's a little bit orange from the colors that are mixing. Well, thanks for joining me today for our exploration of water properties and the magic of water. You guys are all officially now water scientists. So go, search, look for all the places that you can find cohesion, adhesion, surface tension, and capillary action at play in our daily lives. I know that if you look real closely, you'll find way more than you ever expected you would.